Hello students, so in this video we are going to discuss the next chapter, which is about gravitation and this is the module 7 gravitation. So let's start gravitation. So first we'll discuss about gravitational forces, right? So of course here we are not going to cover just theories and all that. We'll focus on problems and the calculation part of it. Okay, so what is Newton's law of gravitation? Newton's law of gravitation. So first thing that we should know is this is a attractive force. Attractive force between any two objects. So you can say that any two objects in this universe attract each other with an attractive force. That force is gravitational force. And what is the nature of that force? How that force works is that the gravitational force is proportional to the product of masses, and it is inversely proportional to the square of distance between them. So here when we are considering the object is like a point object. Okay, so this you have to understand. The objects are point objects, or you can say that they are called particles. Particles has no dimension, right? So it's like a point mass. So what does that mean by point mass? So point mass is an ideal concept, but we can understand point mass in reality by considering the distance between the object to be very large. Okay, so suppose if r is very large as compared to the size of object. So the separation between the object r is much larger than the size of the object. Then in real life we can consider the objects as point object. For example, the stars are very far away from us, but in the night we see the stars twinkling and it looks like a point, isn't it? Although the star is very large, it is tremendously large, but it seems like a point because we are very far away from it. So that's what is meant by point object. Okay, then what about this force? Does it depend on the medium? No, the gravitational force does not depend on medium. It is independent of medium. That means medium does not influence the gravitational force. Okay, and then how do we calculate the force? So if you write this, remove the proportionality constant, you will get a proportionality symbol. You remove, you will get a constant to proportionality, that is called capital G m1 m2 by r square. Okay, that's the force of attraction. That means this force is attractive, means if I have to show the direction, I have to show like this. Of course both the force are same. Okay, this is the first body and this is the second body, but the magnitude of force will be same. Don't think the magnitudes are different. Magnitude of the force is same, right? But the direction of force is different. The force acting on the first body is towards right, and force acting on the second body is towards left. It is like the interaction between the two bodies, and it's like action and reaction forces, right? Okay, so in vector form also we can represent it, but no need to do that, because we can anyway represent it by magnitude or direction also. If you want to write, you may also write the direction. Okay, this is what is force. And always note that it is always attractive. Can gravitational force be repulsive? No, gravitational force has not been found to be repulsive in nature. It is always attractive. But a hypothetical we can make. We can make hypothesis or imagination. Anything is possible in imagination. In that case, you have to consider, repulsion. So you can make, a concept of negative mass, right? So you can say that this is a hypothesis. Okay, so similar masses attract, and opposite masses repel. Although there is no such concept of opposite masses, but we can make a hypothesis. What is hypothesis? Hypothesis is a imagination which we can do, isn't it? Because human mind is more advanced and we can think of things beyond the reality which is existing, right? In front of us, something which is not in front of us also we can think about it. Okay, so but what is the use of this hypo? It will be useful in some cases. In problems we'll see that when we are subtracting some masses from a system of mass. Okay, that time we'll see. Just like in charges, opposite charges attract and similar charges repel. Here it's just the opposite hypothesis. Similar masses attract and opposite masses repel. Okay, and we can do calculations based on it. Okay, so let us now see the value of the capital G. Capital G is 6.67 into 10 power minus 11 Newton into the square per kg square. This is the SI unit of G. Now force is a vector quantity. If you want to represent force in terms of vector, let us say this is the first object, point mass, and this is the second object. You can represent this. Let us say this is the first object, this is the second object, and if I define a vector like this, which is position vector of 2 with respect to 1. If I define like this, position vector, so force on the first one will be in this direction of R21. What is R21 basically here? R21 vector is position vector of 2 minus position vector of 1. Similarly, R12 vector is position vector of 1 minus position vector of 1. Okay, so we are defining it like that. We are defining by this symbol. R21 means position of 2 with respect to 1. R12 is position of 1 with respect to 2. Okay, so in this case, if you want to write the force on 1, this you can write as F1, and force on 2 will be in this direction, that you may represent as F2. So can we represent F1, F2 in terms of vector? Definitely we can represent. So F1 vector magnitude, you write G, M1, M2, these are masses by distance. Distance is R21. Okay, but the unit vector now you have to multiply. Vector is a magnitude and a unit vector. So what is the unit vector? That F1 is going in the direction, that means going from 1 to 2. A unit vector, that means it is R21 cap you can multiply. So that is R21 cap. R21 cap. Now if you want, you can further open this G M1 M2 by R21 square, and R21 can be written as R21 vector by R21 magnitude of that, right? So this in terms of vector, F1 vector can be written as G M1 M2 by R21 cube and R21 vector. Now here this Q factor is coming, but you need to note that this is R21 factor here, isn't it? This is R21 factor. So this is the magnitude, and this is not unit vector. R21 vector is not unit vector. R21 cap is unit vector. Okay, but in this term also it can be represented. We can write it in this form also. Similarly, F2 factor can also be written. You can simply write F21 is minus of F1 vector. This you can simply write, but if you want to write in terms of that, so you may write Gm1m2 by R12 cube, or if you want first in terms of the square you write, and then cap, so R12 cap. Now in terms of cube, if you want to write, so F2 factor is Gm1 m2 by R12 cube, and this is R12 factor. Okay, so like this also you can say that this is the vector representation where the symbol have specific meanings, right, which you can decide by yourself. Okay, this is what is the vector representation of the forces. Now let us understand how do we do calculation. So let us take a simple thing that if you have to calculate force between 1 kg, 1 kg. So 1 kg object, very small point masses separated by distance of 1 meter. So the gravitational force between them is Gm1 m2 by r square. Sometimes we put a symbol of minus here, just this minus shows attraction. Okay, minus, the symbol minus shows attraction. So if you want, write minus, otherwise just magnitude only. If you calculate, then you can just write F is equal to Gm1 m2 by r square. Okay, then what else? We can just substitute the value. So this value is 6.67 into 10 power minus 11, and 1 into 1 by 1 square. So you can see the force of attraction 6.67 into 10 power minus 11 Newton. It's a very, very, very small force. So it is negligible. You can say it's a negligible amount of force, right? Okay, then let us take another question. So suppose that there are three particles, and because of attraction between them, they are undergoing circular motion. So let us say that they are undergoing circular motion due to mutual attraction between them. Due to mutual attraction. 3 point masses undergo uniform circular motion. Find their speed. What will be the speed of each mass? So these three particles, right, are going in a circular motion. So let us consider this is the center of the circle, and you may join this. This will be the radius of the circle. Let us say this is the radius of the circle, and we need to find out the speed, right? So it's going in this direction, let us say anti-clockwise. Each of them has same speed. So if you want to see the resultant force on any one of the mass, that net force will be towards the center, because it's a uniform circular motion. Net force is towards the center. So now let us try to find out the force. So force on this will be along this, right, along this direction. F, and force on this also will be along this direction. Both forces will be equal, right? So just draw the free body diagram of any one of them, so you will see that this is the force and this is the force, right, due to the other two. So these two forces and this angle is of course 60 degree. So resultant force or net force will be 2 times F cos 30 degree, isn't it? So root 3 by 2 to 2 will get cancelled, root 3 times F. That is the net force. What is this force F? It is between individual, right? So G, M1, M2, each masses are equal, let us say M into M. By distance, what is the distance between that? So let us say that this is a perpendicular here and this is going to be 30 degree. So R, this distance, if you see, this is R cos 30 degree, right? Similarly here, this distance is also going to be R cos 30 degree. So total distance is going to be 2R cos 30 degree. Okay, so distance between them becomes, and of course root 3 by 2, so this is root 3 times R. That's the distance, right? Okay, so here also we need to do that. Let us find out force G, M1, M2 by R square. That distance is root 3 R, whole square. So this force F is GMM by root 3 R square, GM square by 3 R square. So the net force is root 3 times of this GM square by 3R square. This is centripetal force, mv square by R. So from here we calculate, right? So R got cancelled, M got cancelled. So velocity comes as root 3 will also come in the denominator. So Gm by root 3 times R. Okay. So this we can understand. This is the velocity with which each of the masses are moving, right? So similar model questions can come and you can work out questions on this, right? Thank you for attention. Then we'll see you in the next class.